By class, today we are going to discuss numerical, which is based upon the Coulomb's law. So as you know, see the expression for the Coulomb's law, the force of attraction or repulsion acting between two static charges is given by F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. So already we have discussed about this formula. Today we are going to discuss a numerical which is based upon this formula. So let us discuss the question. The question is, two static charges plus 9e and plus e are separated by a distance a meter. Where should we place a third charge such that that charge should be in equilibrium? Right now, so we have to place the third charge such that the third charge will be in stable form. So suppose if we are keeping the third charge here, whatever the magnitude is, I am assuming it is q. So because of this plus 9e, the direction of the force acting on this q charge is in this direction. Let us assume the force is F1, right now. And because of this plus e, again you will get the repulsion force in this direction. Let us assume that force is F2. Now the condition is given in the question, the third charge should be in a stable form. But you can see here, because of these two static charges, the force acting on this third charge is in the same direction. That is why both the forces are forcing a net force in this direction. So that charge will move in this direction. That means this charge will not be in equilibrium state. Right? So this case is not possible. You cannot place the third charge in this direction. Similarly, if you place the third charge here, again similarly, because of this plus 9e, the direction of the force in that direction, and because of this plus e, you will get in the same direction. Again, you will get the net force in that direction, and the movement of the charge will be there, and the third charge will not be static. Now, if you place, so this case is also not practically possible. If we place the third charge here, in between these two static charges, now just check the direction. Because of this plus 9e, the direction of the force acting on this third charge, assume it is q, is in this direction. Let us assume it is F1, right? And because of this plus e, the direction of force in this direction, because it is a repulsive force, plus you will get the repulsive force. So in this direction you are getting the F2. Now you can see here, this time both the forces F1 and F2 are opposite forces. Right now, so here there is a possibility these two are equal in magnitude and the third charge will not experience any net force because both get cancelled out. So here you are getting a chance. So these two cases are practically not possible. So I am erasing these two cases. So this case is possible. So assume the point where the q charge is placed is P, right now, and from this plus 9e, this P point, the separation is x. Here I am assuming, and from this P point to this plus e, the separation is a minus x. Right now, because the total separation is a, that is why if this one is x, so this one will be a minus x. It is given in the question, the total separation between this plus 9e and plus e is a, that is why this one x and this one is a minus x. So just note down the values of the F1 and F2. So the value of the F1 is what? Which is the force acting between this plus 9e and this q charge. So we have k q1 q2 upon r square. So k q1 q2. So here you will get 9e into q divided by the separation square. So separation is here x. So that becomes x square. Clear? And similarly, what you will write the value of F2, which is the force acting between this E charge and Q charge. So that becomes K E into Q divided by the separation, which is A minus X whole square. Clear now? So here you are getting the expression for the F1 and F2. But for the equilibrium, these two forces F1 F2 should be in equal and opposite. So, for equilibrium of Q, F1 is equals to F2. Clear? So put the values of F1 and F2. So you will get K 9EQ divided by H square is equal to KEQ divided by a minus x का whole square. Clear? So just see the simplification. So here the k and k get cancelled out, eq and eq get cancelled out. So what is the remaining factor? You will get 9 by x square is equal to 1 upon a minus x का whole square. Clear? So we have this kind of expression. Now you can write this 9 by x square is 3 by x whole square, right now? And this one will be 1 upon a minus x whole square, because 3 by x here, 3 square you will get 9 and x square already is here. So this is the kind of arrangement is here, x square is equal to p square, right now? So when you take the square root, x is equal to plus minus under root p square of p. You will get similarly, because it is a quadratic equation, you will get the two factors of this x. So similarly I am writing this square root. So 3 by x is equal to plus minus 1 upon a minus x. Clear? So for positive sign, you have to take one by one. First I am taking the positive sign. So 3 by x is equals to 1 upon a minus x. Just cross multiply. So you will get 3a is minus 3x is equals to x. Or you will get 4x is equals to 3a, or x is equal to 3 by 4a. So this is your first answer. X is equal to 3 by 4a when you are taking the positive sign of this quadratic equation. Clear? Now next I am taking the negative sign. So when you take the negative sign from this expression, you will get 3 by x is equals to minus times of 1 upon a minus x. Clear? So just cross multiply here. So you will get minus 3a minus plus 3x is equals to x. Just minus a minus x I am multiplying here. So after simplification, that x become 2x is equal to 3a, or x is equal to 3 by 2a. Right? Or you can also write this x is equal to 3 by 2a is 1.5a. Right? 1.5a. Now check the practical feasibility of both the answers. This first answer and this second answer. Just check it. X is equal to 3 by 4a means 0.75a. That means this value is lesser than a. That means the point P will lie in between this plus 9a and plus a. So this answer is possible because this x value is in between this plus 9a and this plus a. But see here, x is equal to 3 by 2a or 1.5a. 1.5a means beyond this e, right now, because 1.5 times. So from plus 9e to this a is a, and after that 0.5a. So if for this answer, the point P or the Q charge should be placed beyond this plus e. And already we have checked, the third charge will be stable when it is placed in between these two charges. So this answer, the second answer, when we are taking the negative sign of this quadratic equation, in that case, practically not possible. So according to mathematics, because it is a quadratic equation, we are getting the two answers. But according to physics, this second answer is practically not feasible. Clear? So we have only one answer, x is equal to 3 by 4a. So this is the answer, the position of the third charge from this plus 9e charge. If in the question it is asked, what is the location of the third charge from the plus e charge? So from plus e charge, the separation is a minus h. So simple, you can find the value. So required distance will be, it is 3 by 4, so that will become 1 by 4a. So from 9e to p, it is 3 by 4, and from plus e to p, it is a 1 by 4a. So if it is asked from the bigger charge, so you will write this answer. If it is asked the location from the smaller charge, then you will write it is the 1 by 4a. Right now? So this is your question. Similar type of questions are given in the book, in place of plus 9e and plus e plus 16 and plus e, like similar questions are given. So the procedure is same, right? Now only this equation, whatever the equation is formed here, only it is changed. So you should solve as more questions which is related to this type of form, and if you have any doubt, you should mention in the comment section. So let us discuss one numerical which is based upon the electric field concept. So as we know that the electric field due to the point charge is given by E is equal to 1 upon 4 pi epsilon naught Q by R square. So this is the formula for the electric field due to the point charge. So here the question is, find the electric field at the midpoint of an electric dipole. We have to find at the center point of this electric dipole axis what is the electric field is here because of these two charges. So the procedure is same. First we have to note down the individual electric fields at this point, and after that, because electric field is a vector quantity, so after that we will take the vector sum of the two individual electric fields, right now. So because of this, so this is the dipole which is formed by this minus q and this plus q, and I am assuming the separation is A and A, or you can also take the L or L right now. So because of this minus q charge, here you have to find the electric field. So electric field, how can find this one? By placing a test charge. So if you place the test charge here, so because the test charge nature is positive, you will get the direction of the electric field in this direction and say it is E1. So what is the E1? E1 is the electric field at this point O due to this minus q charge, right now. And why I am taking the direction this side? Because the direction of the electric field is in the same direction of the force acting on the test charge. So if you place the positive charge here, because of this minus, the attraction force will be there. So the direction of the electric field is in towards the minus q charge. Clear? Now for this plus q charge, if you place here, so you will get, because of this positive charge in this direction, that is E2. Clear? So here, this is the E2. Because again, this is the positive charge. So because of that positive charge, you will get the direction of the electric field in the same direction of this one. So just find out the values of the E1 and E2. So the E1 is, I am writing the K for the simplified form of the 1 upon 4 pi epsilon naught. So K, Q, so because of this minus sign, already I am indicating the direction there, that is why I am not taking the minus sign. So KQ divided by the separation is A, that is why A square. And similarly for the E2 is K plus, again this is Q divided by A square. And because both the vector in the same direction, so you will get E net is equal to E1 plus E2, E net is equal to E1 plus E2, and because you can see the expression, both are in the identical, same, that is why that is equals to 2 times of E1 and put the value, so that become K 2Q divided by A square. So this is your E net. Okay. So the E net will be 2 times of Q upon A square. This is your electric field at this midpoint of the this electric dipole axis.